Yarn, the resource manager for Hadoop. Yarn is a resource manager layer that sits just above the storage layer, HDFS. Yarn interacts with applications and schedules resources for their use. Yarn enables running multiple applications over HDFS, increases resource efficiency, and lets you go beyond the MapReduce or even beyond the data parallel programming model. When Hadoop was first created, this wasn't the case. In fact, the original Hadoop stack had no resource manager. These two stack diagrams show some of its evolution over the last 10 years. One of the biggest limitations of Hadoop 1.0 was its inability to support non-MapReduce applications. It had suboptimal resource utilization. This meant that for advanced applications such as graph analysis that require different ways of modeling and looking at data, you would need to move your data to another platform. That's a lot of work if your data is big. Adding Yarn in between HDFS and the applications enabled new systems to be built focusing on different types of big data applications, such as Giraffe for graph data analysis, Storm for streaming data analysis, and Spark for in-memory analysis. Yarn does so by providing a standard framework that supports customized application development in the Hadoop ecosystem. Yarn lets you extract maximum benefit from your datasets by letting you use the tools you think are best for your big data. Let's take a peek into the architecture of Yarn without getting too technical. In this picture, notice the resource manager in the center and the node managers on each of the three nodes on the right. The resource manager controls all the resources and decides who gets what. Node manager operates at machine level and is in charge of a single machine. Together, the resource manager and the node manager form the data computation framework. Each application gets an application master. It negotiates resources from the resource manager, and it talks to node manager to get its tasks completed. Notice the ovals labeled container? A container is an abstract notion that signifies a resource. That is, a collection of CPU, memory, disk, network, and other resources within a compute node. To simplify and be less precise, you can think of a container as a machine. We looked at the essential gears of the Yarn engine to give you an idea of the key components of Yarn. Now, when you hear terms like resource manager, node manager, and container, you will have an understanding of what tasks they are responsible for. Here is a real-life example to show the strength of Hadoop 2.0 over 1.0. Yahoo was able to run almost twice as many jobs per day with Yarn than with Hadoop 1.0. They also experienced a substantial increase in CPU utilization. Yahoo even claimed that upgrading to Yarn was equivalent to adding 1,000 machines to their 2,500 machine cluster. That's big. Yarn's success is evident from an explosive growth of different applications that the Hadoop ecosystem now has. Due to Yarn, you can use the tool of your choice over your big data without any hassle. Compare this with Hadoop 1.0, which was limited to MapReduce alone. Let's review a summary of the key takeaways about Yarn. Yarn gives you many ways or applications to extract value from data. It lets you run many distributed applications over the same Hadoop cluster. In addition, Yarn reduces the need to move data around and supports higher resource utilization, resulting in lower costs. It's a scalable platform that has enabled growth of several applications over the HDFS, enriching the Hadoop ecosystem.